So yeah, beyond Snuffleupagus, but I guess the actual title of the talk has already been given away. So it's Beyond Shuffling, Tips and Tricks for Scaling Spark. And I'm going to throw in a sneak preview of structured streaming because it's new and everyone likes new, exciting, shiny things. They distract us from the sadness that is life. Okay. So I'm Holden. My preferred pronouns are she or her. I have it tattooed on my wrist in case you forget. And I'm a software engineer at IBM's Spark Technology Center in San Francisco. Just like almost all of the companies that are here, we are always looking for good people. And I haven't figured out how our referral system works, but if you are interested in working with me, I would love to chat with you after this talk. And I've previously worked at a bunch of interesting places that were all a lot of fun, sort of doing search and recommendation problems. And those problems very quickly become big data problems, hence how I am the person I am today. I'm a co-author of Learning Spark and some other Spark books that I'll try and get you to buy several copies of. You can follow me on Twitter for a really, really depressed Canadian watching America. What did y'all do? Thank you. I've got slides. They're not as depressing. And business numbers and code. And when the videos that I get don't suck, I put them on YouTube. And you can check them out here. There's some videos of similar talks and sort of more intro talks if this stuff goes over your head. Or if this is boring, I've got some more advanced talks too. And just to make it really clear, yeah, I'm trans, I'm queer, I'm Canadian, I'm part of the leather community, and I'm really sad with what y'all did. And if y'all need a hug today, you can come find me and I'll give you a hug. If y'all did mean things, please don't do them again. If your family did mean things, please tell them not to. I like living here. And I want to keep living here. And okay. Anyways, so happy software time! Yay! We're going to be excited and optimistic. And I have graphs that imply optimism. So 2016 hasn't been all shit. We've written a whole bunch of really awesome Spark code. Look, it goes up and to the right. That is a good thing. And the Spark Technology Center, which employs me, does a whole bunch of awesome things and is involved with the Scala Foundation and a bunch of other places as well. So if you're like a really excited Scala person, I think you should come and chat with us. Even if I can't recruit you, I love just chatting with more Scala people. And I have a graph which strongly implies that we do a lot of work. Strongly implies. And this graph may or may not have been selected because it's the one where my employer is in the first position. But more realistically, I think it's fair to say we're in the top 3 or top 4. And for starting from nothing, that's pretty awesome. And so if you buy IBM support contracts or have a mainframe, keep doing that. I like getting paid. And if you don't buy support contracts, I don't get paid. I think. No one's made it super clear where the money comes from. So just keep that party rolling. Okay, so more seriously, we're going to talk about a bunch of Spark stuff and not just random shit. I'm going to start with sort of my assumptions about y'all as an audience. We'll talk about reusing data in Spark. We'll talk about some considerations for working with key value data. We'll talk about how Spark SQL and DataFrames can be really awesome. We'll also talk about where they're going to be really sad so that we know when to use them and we don't repeat 2016. And we'll also do a brief introduction to structured streaming. And so we can essentially think of this talk as going from this pissed off cat, which is going to claw our eyes out, to this kind of happy unicorn. And in case you can't read it, it says, "I can't believe it's not MapReduce." So I'm hoping you're all nice people. I'm hoping you don't object to pictures of cats or David Hasselhoff. I gave this talk in Germany once. David Hasselhoff did not go over so well. How many people know some Apache Spark? Okay, and now I know this is going to be really intimidating given the answer to the previous question. How many people don't know some Apache Spark? And it's okay, I just want to know. Cool. That's awesome. So parts of this talk aren't going to be super amazing for you two, but we can chat afterwards, and there will be some good follow-up resources that if I trick you into thinking this is fun, you can use to help understand more of this. And you're probably no longer distracted with Pokemon Go, except if you are, come find me after the talk, because I need to find a Lapras. So what is Spark? Well, for those two, it's a general purpose distributed system. It has really nice APIs. It's written in Scala, but it also has a Python API and an R API. It's a really active Apache project. And while I have some feelings about how the Apache Software Foundation runs, I think it's really good to have sort of more than just one company involved and have this overarching governance. So that's kind of important and useful, so you don't have to worry about us like running off and trying to like make this closed source or something. You can keep relying on it. And most of you came to this because it's faster than MapReduce. For those of you who maybe started working with large data problems after MapReduce sort of had its heyday go down, you maybe came just because your problems were no longer fitting on a single machine, and you were like, so what do I do now? Like, seriously? So cool. RDDs are Spark's primary abstraction. We can think of it as a distributed collection, and it works pretty similar to distributed collection, except for the times when it doesn't. DataFrames, if you're from a Python background, you need to lower your expectations, but they're really awesome. And datasets give us a compile time type version of DataFrames, and they're fun. Spark context is sort of our window to the world, and for anyone upgrading from Spark 1.6 to Spark 2.0, whenever I say Spark session, you can just replace it with SQL context in your head, and it'll be close enough. Yay, different pieces of Spark. But this is important. We've got structured streaming now. Exciting! We can have streaming data with a SQL engine. And I'm lazy, so that's great. The language APIs, although here we're going to focus on Scala because y'all like Scala, hopefully. The graph tools part is a little sad. Don't use them. They don't like they're not maintained, but for some reason we still ship the artifacts, so please don't use them. And then there's community packages, which contains alternatives to this stuff that isn't maintained anymore, as well as a whole bunch of other exciting things, like tools to test your Spark code and stuff like that. And I was really excited that there was a talk on ScalaCheck, because I think ScalaCheck's really awesome. And there's community packages to make Spark work with ScalaCheck, so you can like automatically generate data, and it's exciting. But the sort of takeaway from this slide is Spark is more than just a distributed system. It's a whole bunch of tooling built on top of that distributed system to make it really easy. And it all works together. So rather than having to like install Hive and then install Mahout and like a whole bunch of different tools, you can just install Spark and like give it a list of packages, and you don't have to copy your data between systems. So, I mean, most of you seem to already know Spark, so that was probably boring, just like this cat. Okay, so you may have thought that by coming to this talk, you were going to get away from the word count example, the dreaded word count example. No. I have a big data license, and I don't want my big data license taken away. So I have word count in every single one of my talks, not a guarantee, so I can maintain my big data licensing. But let's look at this big data license approved word count. Now, some of you might be suspicious because it looks like that cat over there is going to have a bad time, and the error code 417 is also like not a good number either. So okay, this is maybe not what we want to do, but if you're looking at this code, it looks pretty reasonable, right? We're loading in some data, we're tokenizing it with the string tokenizer of spaces. It's kind of shitty, but whatever. We're making these word pairs, and then we're grouping them together by key. And then we're just computing the number of words for each individual word. And then we also go ahead and we're like, well, that's interesting, but oh crap, I should have changed that to errors, whatever. I also, I'm processing some log files, so I'm actually really interested in knowing how many of the individual lines contain the word error, because like maybe I'm worried about how many times I'm getting stack traces, But okay, so this looks pretty reasonable, but what's wrong with it? Yeah! groupByKey. So groupByKey is going to be the second one, and we'll talk about the other one first. So I skipped the slide, so you might have already seen it. What is the second thing wrong with this slide? What? Oh, the flat map? The flat map's okay. Like, flat map's fine. Right, we don't cache the RDD. So that's the problem. In Spark, when we use our data twice, we need to give Spark a hint to let it know that we're using it twice. And we can specify all of these different cache levels. Really, for the most part, you probably memory and disk are the two that you care about the most. And also the _2 and checkpointing are the things that other people don't often think about. How many of you run in a shared cluster environment? That's a lot of people. Do you ever experience job preemption? Anyone? OK, I'm seeing some nodding heads, but not a lot of hands. So we'll pretend that you do. So if you experience job preemption, that can be really challenging if you have RDDs, which are really expensive to compute, right? Because Spark will handle that just fine, right? Like our job will complete, but we'll spend a lot of time recomputing things, especially the really expensive things. If we have like a stage that takes like 8 hours, it's going to be really painful when we have to recompute like parts of that 8-hour stage. So we can actually just tell Spark like, yeah, this data is actually super important. Put it on 2 machines for me, just in case. But if your data is like actually incredibly important, and like it took you 8 hours to compute and involved a bunch of shuffles, so that like Spark can't do its really awesome part where it just recomputes a narrow slice of the data, it actually has to recompute the entire data, you might find yourself considering using checkpointing. And checkpointing is not really labeled in the documentation as something that you would use for this, but it works really well. What it does is it sort of goes back to the old MapReduce days and says like, I'm going to write this out to persistent storage, and if my cluster disappears in the middle of the night, it's going to be okay. I'm just going to go back to persistent storage and read this back in. And when you checkpoint, you should always cache, because if you just checkpoint, you'll have to read it back in from persistent storage right away, because checkpointing is an action which actually forces materialization of your RDD. But if you cache and checkpoint your really expensive data, it'll go a little bit better. Awesome. So the other problem is that we were doing groupByKey. And groupByKey is bad, but there's a bunch of other bad things that we can do with key value data. And how many people in the audience would describe themselves as engineers, like data engineers? OK, that's most people. How many people in the audience would describe themselves as data scientists? It's like 5. Cool. So for those 5, you probably got this, right? You're used to thinking about what the distribution of your data looks like, right? Like, that's your bread and butter. For the data engineers, we're often used to like building really cool pipelines and being like, no, I got a bunch of data. It's going from A to B. What you talking about distribution? No, it's cool. But I think as data engineers, it's important for us to steal some things from the data scientists. And as we're working, just be more aware of what the distribution of our keys look like, because we can really sort of screw ourselves up if we get into places where we have large amounts of key skew. And this won't always be obvious, right? Like sometimes our jobs will just start running much slower than they used to, and the problem can be that the distribution of our data has changed, right? Like we did some local marketing in one place. Yeah. So key skew is important because it occurs naturally in a lot of data, right? If you've got stuff grouped by zip code or really anything with humans, you tend to get a lot of key skew. Even a lot of other distributions end up having a lot of skew towards one value, especially if that value happens to be null. Null tends to be the most popular value of my keys because I work with the cleanest of data. And this can be confusing, right? Because we're used to dropping null records from our data when we're thinking about what the distribution looks like. So we can be like, no, it's evenly distributed, it's fine. But it's like, no, oh crap, 80% of my records are actually null. Fuck. And groupByKey will explode. It's easy to make groupByKey explode, but this key skew could actually impact our other operations, right? Our unbalanced partitions could cause sort_by_key to fail, right? And like, you don't think about sort_by_key failing, right? Like, I'm just sorting my data. What could go wrong? A lot of things. Even if you don't have like failures, you can end up with stragglers, right? You're going to have a lot of data that's being processed on a single machine, and that's kind of not the point of Spark. The point of Spark is to split up our work. So most people already know groupByKey is evil, just like this cat. And the part about groupByKey that's evil is that it groups all of the records with the same key into a single record. And part of what makes groupByKey so confusing to people about it being evil is that in a lot of cases when we ask Spark to do a bunch of things, Spark is able to be like, oh, you did these 3 things in a row. I'm just gonna like push them together and like I can optimize the hell out of this, right? Like part of the awesome part about Spark is we don't have to think about like I did a map and then I did another map. Can I actually put these 2 together or like put these 2 pieces of data together and do a bunch of things in a single stage? Like Spark does that for us. But there's this catch. It's not able to help us all the time. And that's the problem is it can't see inside of our lambdas, right? So when we did our groupByKey and then afterwards we did a map values with a sum function inside of it, Spark can't see inside of what we've told it to do inside of map values. It doesn't know that we want to compute a sum. All it knows is that it wants this giant list and we want to do something on that giant list. With the natural exception of Spark SQL and DataFrames, where instead of taking arbitrary lambda expressions, we take SQL expressions. And this is really important because when we are working with SQL expressions, Spark is actually able to understand what we're doing, and it can actually pipeline these operations for us. And groupByKey becomes safe. And so this is my handlebar mustache example. So let's say that I've given up on tech because of reasons that do not bear going into. And I've decided I'm going to open a mustache wax store in San Francisco. And to do that, I need to know where the most handlebar mustaches are. So naturally, I want to compute the distribution of handlebar mustaches across our fine city. But the problem is I called groupByKey and then I got this giant record, and red is bad. Red means failure. So this record is too big to fit in our single machine. And that's sad. But it's OK. We can actually just compute this another way, right? We can give Spark the opportunity to use reduceByKey. So instead of our groupByKey here, we're going to go ahead and we're going to use reduceByKey. And really, anytime you find yourself doing groupByKey, you should wonder if you can solve it with reduceByKey or aggregateByKey. And in those cases, Spark can actually see, oh, this is the operation you want to perform. Right? Like I can start aggregating my data together. I don't have to make this giant list. I can aggregate it sort of incrementally. And this is genuine big data, 48 kilobytes. But we can see here this is groupByKey, and I wanted it to actually succeed so we could see the difference. So this is 48 kilobytes, and then if we do reduceByKey, we see our shuffled read is 11 kilobytes. And 11 is smaller than 48 by a factor of 4. So that's good. Well, not quite, but close enough. So why is that? It's because we get this free map side reduction. And what that means is when we use reduceByKey or aggregateByKey, not only do we get the benefit of like having our job actually work, even if it would have worked otherwise, we get this benefit that we combine the data on each individual worker before we start sending it across the network. So if you've got some duplicate keys on some of your workers, it'll get reduced a lot beforehand.
I have a question.
Wonderful.
If you needed to, let's say that the distribution of the keys are not too skewed. I have like maximum, maybe 5,000 for each key.
Yeah.
Maximum. I could use reduceByKey and build a model.
Yeah. So if you have at most like 5,000 records for, okay. So the question is, I'm going to rephrase your question because I think you meant something else. And if I didn't, you can correct me. So the question is like, if my distribution isn't too skewed, like, can I just use groupByKey? Is there anything wrong with using groupByKey? And the answer is like, no, you can use groupByKey. The question is like, is there any benefit to using groupByKey for your operation? Like, if it's a lot simpler to write with groupByKey, and you know for sure there's only 5,000 records for each key, then you're good.
Let me give you an example. If I needed to build a logistic regression and a bunch of, and I know that I don't have
Sure.
points for that.
Yeah, yeah.
I have the whole set at once.
So that's fine. Yeah, if you're building something where you have like you need to build a separate LR for each thing, and you've got like a few thousand points for each key. Like, it's okay. You can do this. I'm just going to be giving you some side eye. And like, don't be surprised when your data source changes and everything goes to hell. Sorry, I'm a bit cynical. It's taken a few years, but
So
yeah.
It's also called a healthy paranoia.
Right, yeah, no, I've dealt with too many data sources where someone's like, no, our distribution is totally 100% not skewed, I assure you. And then I'm like, 80% of your records are null. 80.
It doesn't need,
What the hell?
you only need one.
Right, like, and what works today may not work tomorrow, right? Like, data sources change. Frequently without my involvement, hopefully, because like, I'm really lazy, and my desire to get paged at 2 o'clock in the morning is pretty low. I stopped working at Amazon for a reason.
Continue your point.
Shout out to anyone working at Amazon with a pager. I feel your pain. Sorry.
Continue your point. If we know that groupByKey doesn't crash, so what would be the benefit?
So, right, okay. Even if groupByKey isn't going to crash, right, you should still consider using reduceByKey or aggregateByKey because you're going to get this free map side combined, right? So even though groupByKey would be successful, if you can reduce your data on each worker locally first, you'll just have less network transfer and less disk access as a whole, and that's just generally a good thing. There's no magic inside of aggregateByKey though, right? Like if the operation you're doing fundamentally involves creating a list of all of your records, yeah, okay, fine, you can use groupByKey, and it's probably going to break one day, but that's a problem for future you. And now we come to the, oh crap, I forgot to update this slide. Oh well. And now we come to the exciting sorting our data can fail slide. Yay. So there's this unfortunate partition size limit of 2 gigs that we've worked to get rid of a few times, and then always just sort of been like, wow, that's a lot of work. You know what? We'll just tell people to make smaller partitions. And that part's worked out really well for us, in that it's no longer my problem. And it also gives me a slide to talk about. So that's awesome, right? So if you find yourself like running into really weird problems that make no sense during a shuffle stage, you should be like, huh, I wonder if one of my partitions after my like shuffle is like larger than 2 gigs. And if you find that's the case, well, we know why your job's failing. I abdicate all responsibility and tell you to make more partitions. But there's a catch, right? If we're sorting by key, there's sort of this limitation, or even if we're using a hash partitioner. If a lot of our data has the same key, Spark uses these partitioners concepts, which are really awesome, but they have to be deterministic. And so what that means is all of the data with the same key always has to go to the same partition. So if I've got more than 2 gigs of data with the input key, Spark isn't going to be able to split it up amongst 2 partitions for me. Even if I tell it to like shuffle to 10,000 partitions, it's going to send all of the data about my handlebar mustaches to that one partition. And I won't know where to open my artisanal handlebar mustache wax shop. And then this is the sadness, right? Like, I can't do my direct mailing campaign about handlebar mustache wax. And that's just a terrible thing for the economy. But it's okay. There's a solution. And you too can send spam about handlebar mustache wax. OK, right. And here is the bug, which most people wouldn't notice, but one person did once, and I forgot to fix it. This key. Oh, wait, I fixed it. Never mind. Everything is perfect. Everything is fine. No questions. No questions. So more seriously, sort of the solution to our handlebar mustache problem, which is a much more fun name for sort by key, is we just need to allow Spark's partitioners the opportunity to introduce splits, right? So we need to give it some sort of extra noise which it can partition on. The easiest source of noise is just like grabbing part of our value and using it as noise. And that's fine, and that works really well. And you might be going like, yeah, but Holden, this data is really not good, right? Like, I don't actually want to send direct mail to 94110_A. The post office is not going to deliver my direct mail ads, right? And that's okay, because after you've done your shuffle, you can immediately do a map, and you can get rid of this junk part. And you'll end up with having 94110 across 2 partitions. And I told you that was impossible, but it's just impossible when it's been sent there by a specific partitioner. And it gets sent by a specific, so essentially when we do a sort by key or a repartition, Spark uses a partitioner to figure out where to send the data. But when we do something like a map, Spark is just like, well, I'll leave the data where it is, because that's cheap. And then it just doesn't know where to find the records anymore. And then it also removes all of the restrictions about having to have all of the records with the same key on the same machine. And so we can have our success and happiness, and I can send my handlebar mustache wax related ads. So that is it for handlebar mustache related jokes. But there's some secret inside of the shuffle. And it's fun secret magic that occasionally catches on fire and explodes. So yeah, and there's a partial fix, but I argued against making it a correct fix because I was wrong. But I can admit that. Anyways, so there's this thing. When we shuffle our data in Spark, Spark implicitly creates these shuffle files, and they go into our temp directory. And if we shuffle a whole bunch of data, like a lot of times, we could have a lot of shuffle files. And normally this isn't that bad, right? Because our machines tend to be pretty big, right? The only problem is SSDs became really popular, and they sort of like screwed with this whole mentality that I don't have to ever worry about disk space, because now people are just buying machines with lots of RAM and really small SSDs, and now I'm running out of disk space. And I didn't do a real good job fixing that one. So this is also on you. This talk is essentially things we should have done right that we didn't, that you have to work around. That would be a much better title. Anyways. So there's some cool things, though, about these shuffle files, right? I was telling you that whenever we reuse data inside of Spark, we have to tell Spark that we want to reuse it. The exception is if we shuffled our data and then we're reusing it right afterwards, is OK. Spark will just be like, oh, no, it's cool. I wrote that to disk on like that other machine. We got this, right? So we essentially get disk level caching implicitly on shuffles for free. The only problem is we get disk level caching that is completely unmanaged on shuffle files for free. And even if our RDDs go out of scope, right, like even if we've stopped keeping track of them, Spark won't clean them up until there's a garbage collection event on the driver. Notably, your driver running out of memory is not related to your workers running out of disk space. And that's unfortunate, right? So we have this problem where Spark could write a whole bunch of files and we could fill up our disks and our jobs will fail. Now, lovely question. So the question is, if the driver goes down, does that mean that the temp files don't get cleaned up?
I asked because I filled up the temp one time real bad, and the house people weren't very happy with me.
Right.
I was writing some really terrible code at the time, so I was curious if maybe that was the reason.
That actually might have something to do with it, indeed. Yeah, so when your driver program crashes, bad things happen, and I make no guarantees. So try not to do that, and you'll have a much better time. I had this conversation with someone earlier this week where they're like, so I keep getting an out of memory exception in my native code. How do I work around that? I'm like, well, fix your native code, because I don't know how to make that work. I'm sorry. Yeah, really, there's no graceful cleanup. If you're running inside of Yarn, though, it should get cleaned up unless we did terrible things, which we might have done because, honestly, I didn't pay a lot of attention. So we can reuse these files. Occasionally, these files will run out of space, and then we'll be sad. But if you find that happening, you can just add like a system GC event in your driver program and hope that the JVM listens to you. Probably will. What could go wrong? Alternatively, if you look inside of the code for the ALS algorithm in Spark, you can find the part where it explicitly cleans up the shuffle files. It's not publicly available because it's a little flaky, and cleaning up the shuffle files can have some unintended side effects. So use with caution, and I make no guarantees. Yay, more things that are gonna go wrong. Ooh, does anyone use map partitions? Oh, like 5 people? Okay, 6 people. Well, okay, that's not a lot of you. But for those of you that have ever considered using map partitions, you need to be really careful with it. And if you're not going to use map partitions, you don't have to like worry too much. But there's this thing, right? Sometimes we want to process a lot of data, and it's going to be more data than's going to fit in the JVM easily, right? And we want Spark to be able to go like, okay, I've processed like half of this partition. I'm just going to write it out to disk, so I've got some room to process the rest of my partition. And if you write a map partitions incorrectly, you can accidentally make it so that Spark isn't able to do that. So essentially, map partitions gives you an iterator interface, and you always need to make sure that you're returning an iterator, not like an iterable, and certainly not a sequence. And there's a lot of implicit conversions that will just make our lives terrible, and actually take these things and turn them into sequences behind our back and make our code fail, and it'll be sad. So be careful when you're using map partitions, otherwise you'll get an out-of-memory exception one day and be sad. Restructuring your code to avoid turning things into lists can be kind of painful, but it's worth it, trust me. Okay, yeah, this is David Hasselhoff. The Germans didn't like it either. So datasets. Datasets are awesome. They're new in Spark 1.6, and they give us a whole bunch of really great performance. And we added streaming to them in Spark 2.0. Yay! Oh, I should change that. Oh, well, whatever. They're still like experimental-ish. The API is probably going to change as we discover things we did wrong with them. How many people really like writing UDFs? No one. Awesome! So datasets save you from the terribleness of having to write like Hive UDFs. And instead, you can just use like a map function on it and like have your arbitrary Scala code just mixed in with your relational transformations, and it's awesome. So let's look at how to do that. Okay. Ooh, well, this is like interesting. I've got a data set of pandas, well, raw pandas, and I want to find the happy ones. I don't care about the sad ones. And I'm interested in how fuzzy they are, and that's stored as attribute 0. So I select that, and then I'm like, oh, I don't remember how to call the word sum, because let's pretend I was drinking. So I call reduce with this reduce function to compute the sum. And okay, I mean, that's pretty easy. But the interesting thing is we've got these two sort of relational queries followed by some arbitrary Scala code. And this like happy equals 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 true thing is really awesome, because if our data happens to be partitioned by which pandas are happy and which pandas aren't, Spark will go, oh, yeah, that's cool. I'm just going to read the data about the happy pandas. And the fastest data to process is the data that I never bother loading from disk. That shit is real fast. Yeah, arbitrary Scala code. Having to specify the type is a little ugly. We probably could have done this with like macros and happiness, but we didn't. Anyways, awesome things. So this is the part that's actually way more awesome, right? Like calling reduce on the end of like some transformations, like whatever, right? That's not all that exciting, right? But like this part is really cool, right? Like I have a functional map on a data set, and after this map, right, like I could actually just like register this data set as a SQL table and write a SQL expression against it, right? Like I don't have to save it out to disk, copy it to another system. I can just like intermix this in the middle. Or if like some business analysts like gave me some stuff and it was like, oh, it's kind of slow, I just want to rewrite this one piece, I can just go ahead and rewrite that one piece with my like happy Scala code, and then I can put their SQL above it and below it, and it'll work, and it'll be awesome. And I don't have to rewrite their entire thing to make it go vroom vroom. I just have to rewrite the slow bit. And I don't have to write a UDF either, because UDFs are sad. And they can be really fast. This is in Scala, in the JVM. So we all know that groupByKey is bad, but the interesting thing is that DataFrame operations outperform RDD reduceByKey, right? And actually, even if we're doing the same operation many times and we give the JIT a chance to warm up, they still outperform it. And there's a few reasons why. We essentially get this sortable trait for free. And essentially what that means is that our serialized data can be sorted without having to deserialize and reserialize it. So like shuffling data in datasets and DataFrames is much faster than it is traditionally in RDDs. We also get more efficient like storage. So like it's going to take up less space, and that's just generally a good thing. There's going to be less network traffic, so that's also going to help us go fast. And it's generally good. If there's any heretics in the room using Python, you're really going to want to use this, because your groupByKey is still really bad, but reduceByKey is still not that good, right? And that's because there's this sort of like extra overhead of working with non-JVM languages inside of Spark. But DataFrames and datasets let us get out of this sort of extra overhead by taking our SQL expressions and just evaluating them in the JVM.
Quick question. Are datasets much slower than DataFrames or on par?
Huzzah! Wonderful question. Datasets slower than DataFrames, question mark. Answer, they're not the same thing. No worries. So whenever I talk about DataFrame, you can just think of dataset where I was too lazy to talk about the types. But there's going to be a bunch of places where it explodes. So like sadness, just be aware of these things. Whenever we've got new happy things, there will be problems. You need to be aware of them. This is a workaround for lineage explosion. So if you do really, really like iterative algorithms, datasets don't handle it super well. You need to like sort of round trip it through an RDD. The reasoning is, if you want to talk about it afterwards with me, we can have a drink or two. And now we have streaming with them. Yay, streaming! So streaming is the new happy thing, right? Like we're all like, yeah, I'm going to take my batch ETL and turn it into magic streaming code. So let's look at how to do that. OK, before we do, this cat wants to remind you that it's alpha code. So we can look at how to do it. But if you use this in production, it's on you, all of you. And I gave this talk once, and someone came up to me afterwards and was like, so I want to use this in production. Don't be that person. OK. So it's not super important to like look at this code because I'm running short on time. But the interesting thing is, while we don't have data type inference for streaming data just yet, because we can't see or sample the whole data to figure it out, the API is really similar to just the regular DataFrame or dataset API. And in fact, doing our operations, this same code would compile against the regular DataFrame API, right? I can figure out how related coffee count and happiness are. And I think it's just strictly increasing, but there's other people that say it's like a weird function. I don't know why. Maybe at 6 coffees it's bad, but at 8 it'll go back up to happy. Join me in the research. And then we can just start it. And we've got this awesome stuff, and we've got streaming data. And there's just this slide of gotchas that will go by super fast. This is just to remind you, really, really don't use this in production. There's a lot of reasons not to. Cool. There's a whole bunch of Spark resources if you're interested in it. If you're interested in unit testing, please test your code. I don't want another financial meltdown, and I don't want it to be related to software that I've worked on. So test it. If anyone works in banking, please don't fuck it up. I've lost a lot of faith in America. Let me keep some. And there's some like resources. I'll do office hours, and IBM can buy you coffee. And if no one shows up, I can't expense my coffee. So please show up so I can expense my own coffee and answer your Spark questions. You should also buy several copies of all of my books, except for this one, which is out of date. But you should buy many copies of this one because it's the one where I receive the most royalties. And it doesn't even exist yet. The first 7 chapters are available in digital format from O'Reilly. And if you give us a bunch of money, we promise to eventually give you the real book. Videos, I'm running low on time. So if you have questions, come find me in the hallway. Otherwise, thank you so much. You laughed at most of my jokes, if not David Hasselhoff. So thank you.